Alright, so let's take a look at the derivative using the chain rule. So we have find dy dx for y is equal to the sine of x that is raised to the fifth power. If you don't like the way that that is written, you can always write it as y equals, in parentheses, the sine of x raised to the fifth. I won't ever write it like that. If you need to write it like that, please do so, but I will always keep it as the standard way of writing it, which is y equals sine to the fifth of x. So we have two functions going on here. We have the sine of x, that's a function, and we have something being raised to the fifth power. That's going to require a chain. I don't know how to do that. I don't know how to handle that unless we have the chain rule. So, if we think about the functions that we would do, if I gave you an x and you were to plug it in, what you would do in evaluating this function is, number one, you would take the sine, not multiply by sine, you would take the sine, and then number two, you would raise to the fifth power. Those are the two steps that you would do if you were evaluating. Well, since we're not evaluating, we're taking a derivative, we're going to do that in reverse order. So we're going to start with raising to the fifth power. That's the thing that we're going to deal with first. Realistically, if we're doing the chain rule, the way that we had started doing the chain rule is we let u equal something. So we did a substitution. So we're going to let u equal the sine of x, because that's the first thing in my list. So I'll let u equal that first thing in my list. If I do that, then y will equal u to the fifth power. That I can do. I can find that derivative. That derivative is no big deal. The derivative dy du, because its u is the variable, would be 5u to the fourth. We're going to take that, we're going to put that on hold. That's not our final answer, but we're going to need that. Unfortunately, that's not dy dx, which is what the problem is asking us for. The problem wants us to find dy dx, not dy du. So I've got to try and figure out what dy dx is. Well, let's see. I know what dy du is, and what we discovered on the board the other day was basic fractions. If I want dy dx, that's really just dy du times du dx. Because the du's would cross out, and that equals dy over dx. Well, I have that first part. I have dy du. It's right here. So I have this entire fraction taken care of. It's the other fraction that I need. I need du dx. Well, I'm going to need a function that says u equals, hence the du, and it's got to deal with something with x, hence the dx. Well, I've got that. I've got that right up top here. I let u, I picked it, I let u equal sine of x. So I can take that derivative. If I do that, the derivative will be du dx, the derivative of u, and that will equal the derivative of the sine of x, and the derivative of the sine of x is the cosine of x. That is du dx, which I will be able to plug in here. So putting it all together, dy dx, the thing that I'm looking for, will equal dy du, the highlighted in the turquoise greenish, 5u to the fourth, times du dx, the highlight in the kind of gross yellow, cosine of x, and I've got my derivative, because that 5u to the fourth is dy du, and that cosine of x is du dx. So when I multiply them together, I get dy dx. But I can't leave it like that because I don't want to mix variables. So I need to replace u. I can easily just go right back up and see what u is equal to. It's equal to the sine of x. And so replacing u with the sine of x, I'll have 5 times the sine to the fourth of x times the cosine of x. And that is the derivative I'm looking for.